Hello everyone, today I'm going to show you how to use SolidWorks to create this part as well as the orthographic and the section view for this component. So let's go to SolidWorks, and before we do that, keep in mind it's a metric unit, so we want to switch it to a metric. And also let's take a look at the part. So the part, I'm gonna make the part, the sketch as the circle, the bigger circle, and the inside circle, and extrude the whole part. And for the rest of the holes, I'm going to treat them as all holes and use a hole wizard, because if I use a hole wizard, then when I call out, I will be able to include all the informations of the hole. So this is the plan. So let's go to SolidWorks and start a new file and start a new part. Say OK for that. And like we said, the units, they are metric units. So the first thing, you want to switch the units to the millimeter, gram, and second. And I'm going to go to a sketch, and I'm going to create the part on the front view. Go to SolidWorks and select the sketch and do the sketch on the front view. And I'm going to draw a circle, which is the outer one, and also draw the inner one. And I'm going to give a dimension for them. So the bigger one, the diameter is 80, and the smaller one, the diameter is 22. So let's go back here. So the large one, the diameter is 80. And the smaller one, the diameter is 22. And after this, let's save the work. So let's create a new folder that is called Q3. So right click of the mouse in the folder and do new in the folder there and name it as Q3 for question 3, and open that and save the part as Q3 as well. And now the part is saved. After this, we accept the dimension and go back to features and do extruded boss or base. And so it's recognized. Then we let's take a look at the thickness of the part, which is 20. So let's go back here and do the thickness as 20 and accept the change. So right now we're extruding in outer direction. So a lot of times it might be easy if we extrude in both directions in case we want to add other features afterwards. So in this case, I'm going to select, instead of a blend, I'm going to select the middle plane. So it's extruded on both directions. Now let's accept the extrusion. Now we're going to make all the surrounding holes. So like it says, it's 8 holes, they are equal space. So when we create the hole, we're going to use a hole wizard. Like we said, when we call out in the future, it will recognize they're all physical holes instead of some empty parts there. So let's go to hole wizard. Oh, by the way, so the holes, the position is, so the hole's diameter is 14 millimeters, and it's on the space on the 56 diameter hole. So this hole, the center lines, they're all 56 diameter. So let's go back to SolidWorks and go to hole wizard. So hole wizard here, and click the drop down button, and there's a hole wizard. And it will ask us the hole type. So right now we're going to select just a simple hole, which is the third one. the simple hole, instead of a counter bore or countersink. So we just do a simple hole. In the standard, let's do asymmetric. So ANSI, that's a US standard, and since we're doing metric one, so let's do a asymmetric. In the type, it actually doesn't matter. So you could use dual holes or drill size. So I'm going to just use dual holes. And so let's take a look at the size. So the size is going to be 14 diameter. And let's take a look at here. So we actually don't have a 14 because 14 is not a standard asymmetric. So let's just do a 12 here. And we'll be able to specify the diameter later. So right here, so show the custom sizing. So we're supposed to have a 14. So let's change it. So check the show custom sizing and change it to 14 millimeters. So your hole's diameter is going to be 14 millimeters. And the fade you can just keep as normal instead of clearance, interference, or transition. So just keep it as normal. And the end condition is going to be through all. And we don't need any near side countersink or far side countersink. So uncheck those two options. And we selected the hole type. The next thing, we're going to specify the position of the hole. Okay, specify the position of the hole. So we're going to select the positions, and we'll ask us to select the face for the hole or the slot. So we're going to put the hole on this face. So we're going to click this face or this surface and put the hole on the surface. So the hole is supposed to be lined up with the origin. So we can place the hole right here. So this is the overview, looks right to me. And before we leave, we need to dimension the hole, right? We haven't put any dimensions on the hole, so the hole could be able to move to anywhere on the surface. So we're going to give up the dimension of the hole. So let's go back here. So remember the circle, the center line is a circle. The diameter is 56. So from the center of the hole to the center of the origin is going to be half of 56. So let's give a dimension on that. So smart dimension. So as you can see, this is a blue. Okay, this is blue. Like we said, everything has to be fully defined before we move forward. So we're going to select the center of the hole and the origin. So it doesn't let us to select because you're in a 3D sketch. You don't exactly know where the origin is. Instead, you can go here and do the drop down button and select the origin. So origin is actually there because we're in a 3D view. So select the origin and give a dimension, which is, let me double check of the dimension. So which is double the half of 56. So we do 56 divided by 2 and accept the dimension. And after you do that, you'll see it's still blue because this two we haven't tell it's vertical. So they're supposed to be on the same, they're supposed to be vertical. So let's add a relation to these 2 points. So add a relation here. So select the entity. I'm going to select this point first. Then I'm going to select the origin once again. So click the drop down button and select the origin and say they are vertical and accept the change. After that, it should be black. So let's accept the host position. And so the part should be fully defined. It's not saying here. So let's save the work one more time. So by doing this, we created one hole. So another way you can check if it's fully defined is you can expand the hole. So there should be 2 sketches under the hole. One is the position another is the hole's dimension. So both of them, they're fully defined because no minus sign in front. And we only created one hose, and like the sketch, it should be 8 of them. So we're going to use a pattern to create the rest of the holes. So you can go to a pattern here and click the drop down button and do circular pattern and click the pattern here, and we'll ask as the direction first. So we click this space, select the space, and select the circle because this is the direction we want the hole to be placed around all this circle. So we select the circle as our direction, and we want to have 8 holes. So you can put 8 here and check the equal spacing. And for the features, we want to duplicate the hole. So click the feature here until it's blue and select the hole that you just created here. And it should be 8 holes, and accept the change. So this is the part that we made. And let's save the work. So after the part, we're going to create a drawing for the part. So let's click the drop down button here and select make drawing from the part or assembly. And let's select the A size, which is ANSI A size landscape, and accept it. And we're going to put the front view. So let's select the front view and put it on the sheet. And also put as the right side view. Okay, right side view. So like we said, for the right side view, we're supposed to be able to have all the hidden lines there. So after you place the right side view, it will keep going until you hit ESC. So let's hit the escape key so we can work on the view. So let's turn on the hidden lines. So you can click the view here and select the hidden lines. So all the hidden lines will show up. So as you can see, it's going to be pretty complicated because if you look from the right side, so we have one hole here, another here, also the center. So there are a lot of hidden lines here, which is pretty confusing. That's why we recommend you to use a section view instead of a right side view. So as you can see, if we use Hole Wizard, it will recognize they're all physical holes instead of just a cavity or empty part. And some people don't like the symbol like this. So if you don't like that, you can click that and delete that. Okay, if you don't like the symbol, then you could select that and delete them. So they are still holes. And instead of the right side view, we're going to select a section view for the part. So let's create a section view. So you're going to go to a view layout, okay, the view layout tab, and click it. And we have a section view option. So we're going to click the section view. And so the cutting line, the default one is the first one, which we're going to cut vertically. And also you could cut horizontally, then the section view is going to be like this, or you could define how you want to cut it. So today we're going to just use a vertical one, and put your point here and accept the selection. So the section view, we're actually viewing on the to the left side, and this is the section view. So in this case, the section view is a lot clearer than the right side view, because section views we only put what is on the section. We don't put all the hidden lines, so only put whatever is on the section, so which is pretty clear to us. And now let's give a dimension for all these things. And so first of all, let's go back to annotation and give diameters for the big circle. So for the bigger circle, let's go to Smart Dimension and click the bigger circle and give a diameter for it. So right now, as you can see, the dimension is incorrect because this is still under an inch. So let's just accept the dimension and change it to millimeter. So as you can see, the diameter went back to millimeter. And let's dimension the inside holes. So the smaller hole here, let's click that. And I need to select the Smart Dimension first and select the smaller hole and give a dimension for that. This is 22 millimeters. And let's dimension all the small holes. So for the small holes, we could use the hole call out because we drew them up by using hole wizard. So there is a hole call out. So let's select the hole call out and select the hole here and maybe this hole and put the dimensions as this. So this is not, this is a good one actually. So it went out until you find a good one. So this is actually a good position. So I'm going to drop it down here. So as you can see, it's automatically recognized 8 of holes, and each of them it's a 14 millimeters diameter, and they're through all. So that's the reason I ask you to use the hole wizard. And also we're supposed to give a dimension to the thickness of the part. So select the Smart Dimension and click the edge. So this is 20 millimeters. And with that, we are also supposed to dimension the center lines circle. Okay, center lines circle here. So let's go to a center mark. So select the center mark here. And so actually this is what we're looking for, the circular center mark. So select this and let's select one of the holes, and this will show up with the symbol, and if you click that, so the center marks will show up like this, and accept the change. And we're also supposed to give a diameter of the center mark. So do Smart Dimension and give a dimension for the center mark here, which is 28 radius. And if you want to change it to diameter, you could click the 28 and do liters and change it as a diameter. So right now it's going to be a diameter 56, and accept the change. And also as we taught before, everything symmetric, we're supposed to have a center lines for it. So we're going to select the center line here instead of center mark. So click the center line, and I'm going to click everything symmetric. So the center lines is going to be added automatically. So that's 2 as well, and that's 2 as well. So the bottom 2 holes, bottom and the top holes, you may not need that because we already showed them on the front view. But let's just do it right now. So it's a way of studying. And accept the center lines. So if you think it's too long or too short, you could be able to modify it by just click the center line and drag it longer and shorter. And save the change. So we save it as in the same folder. so call Q3 as well. Otherwise, it will not be able to recognize. So in reality, we don't need this right side view at all, but as an exercise, we will just leave it here to make sure you know how to create the right side view and turn on all the hidden lines. And also, we're supposed to have an asymmetric view on the right upper corner, so we can go back to the view palette. And as you can see, the views are no longer here. And you can click the Q3 here, then all views will show up. And we're going to plus asymmetric view. So this is, I can't put it here, so I'm going to screw the mouse a little bit and select the asymmetric view and drag it up here. So as you can see, this is way too big. And from our previous classes, so asymmetric view does not have to have the same scale as other views. So we're going to change the scale for the asymmetric view. So we're going to select use custom scales. And let's do it 1 to 2. We'll see what's going to happen. So this is actually a good one. And for the display style, we're going to use the shaded with the edges one. And so this is good view as well. So let's put it on the right upper corner of the drawing and accept the change and save the work. And also you may want to take a look at all the font. So those words you might feel is too small. Then what we can do is we go up here and go to options and click the drop down button and go to options and go to document properties. And for dimensions, so we click dimension, the font here, you could change it to 16. So first of all, you click the points and change it to 16 and say OK. And if we say OK, then all dimensions numbers are going to be bigger. And since these are all integer numbers, so we may not need the 2 decimal places. So same thing, we're going to go to options and document properties and still dimensions. In the primary precision, we're going to set it as none and say OK. So all the dimensions, they're integer numbers. And the arrow here, so section view, the A might be too small as well. So what you can do is you go to options and the document properties and go to views, because we did the section view. So you do section views and you should be able to change the arrow size, so the arrow text, and let's give it to a 16 as well. So select the point, then 16 and say OK. And you should be able to change the arrow size as well, so which is this arrow here. So if you think it's too small, and the height, so right now it's 2.303, so let's change it to 3.03. And also the arrow's length, you can change it as well. So right now it's 635, so let's change it to maybe 835, see what's gonna happen. And the total length, let's change it to 14 and say OK. So this is the section view. As you can see, they're all turning bigger. And this is a section for AA. And if you think the section AA is too small, then you can double click section AA and change it to 16 as well. So it's a little bit bigger. And as the last thing, let's move all the views around. So make sure it fits well on the whole drawing. Section view. And save the work one more time. looks good to me. Then let's save it to PDF. So do the save as and save it as PDF. So click that. So this is a PDF, and still call it as Q3 and save it. And let's go back to the folder, see what we're going to have in the folder. So this is the folder, and when you go to Q3, it should have all 3 files. And when you turn in, make sure you turn in all of them and make sure they have the same name. Otherwise, I might not be able to open them. The PDF will be fine. So that's 2. They have to be the same name. And that's all we have for today's part. And thanks for watching. We'll see you next time. Bye.